Hello and good evening. I'm Melisa Idris. Welcome to The Future is Female. This is the show where we find the extraordinary in every woman. This week, we're highlighting two Malaysian scientists recognized by the L'Oreal UNESCO for Women in Science program. I have with me, joining me first, is Dr. Noorfatimah Yahaya, Associate Professor at USM's Cancer Research and Specialist Center. Dr. Noorfatimah, thank you so much for being on the show with me today. I want to say first, congratulations on being one of the 3 Malaysian awardees for this program. So kudos to you, and let's learn a little bit more about what you do, about what about your research was recognized by the L'Oreal UNESCO for Women program. So talk to me a little bit about yourself, your journey, and your research.
Okay, all right. Alhamdulillah, thank you very much to Melisa, to Astro AWANI for inviting me for this interview. So actually, tell about my research. Actually, I was drawn to this area when my clinical collaborator from pharmaceutical sciences in USM approached me about the need for a reliable method to measure one antibiotic that we call as unacin, okay, to measure this unacin in human plasma samples or biological samples. So as a scientist in analytical chemistry, especially at the Medical and Dental Institute in Penang, in USM Penang, I am inspired to contribute to advancing the healthcare system in terms of development of reliable analytical method for these biological samples. So in this work, okay, we currently develop an innovative and green and rapid method to measure unacin level or unacin antibiotic levels in plasma. And then after that, we will bring this data, okay, to check the or to develop the optimal dosing for these patients. And the last one will be development of personalized dosing system, the dosing which specific to individual patient. So this research actually providing a solution that improve the risk of toxicity, ineffectiveness of the antibiotic, and improve the healthcare system.
Right. I have a quick question. So I'm a layperson with no medical training or scientific background. So when you talk about unacin antibiotic levels in plasma, so the unacin is currently used, right? It's currently being used in medical treatment. What is the current issue now? What is the problem, if I may use that word, with how it's currently being dosed? Why does it matter that we measure the levels?
All right. So very sorry if I'm using very scientific term, but in layman term, actually this unacin is commonly used in hospital, especially in critically ill patient. So when this unacin used in or antibiotic used for critically ill patient, we cannot tolerate the less appropriate dosing because they are in critical condition. They need the antibiotic to be accurate in dosing. So at the moment, the hospital in Malaysia, they are using the standard general guideline for dosing of this unacin. We do not have specific dosing for antibiotic or for individual patient. But different patient, they have different severity, different factors that can contribute to the outcomes or the treatment outcomes. So we need the specific dosing for this patient.
Amazing. So how do you make sure that there is specific dosing tailored for specific patients? How do you do that?
All right. So the challenge in this study is that we need to collect many data or many sample patients so that we can use AI or machine learning to help us to identify the key predictors of the treatment outcomes. So once we identify these key predictors for the treatment outcome, so we can have we can identify and we know which parameters or factors that contribute to the effectiveness of this antibiotic, and we can do for personalized dosing system for each patient.
Oh, that's amazing. So you're actually using AI to make medicine more personalized. A precision medicine. Is this groundbreaking? Have we been able to use AI in such ways before?
Before this, um, I think there are few attempts to do personalized dosing, but in my case, what is unique about my project and my collaborators in USM is that I actually applied a greener method to measure this UNASIN level. So we actually incorporate a greener and rapid method to identify the level of UNASIN in human plasma samples.
Oh, what does that mean? A
So
greener
when we
method?
have a very rapid method, the personalized dosing system will be developed efficiently and we can make sure that it is accurate and reliable to be used.
I love that. Okay, so this is the research, right? So you have it already, you've been working on this. How many years have you been working on this research?
Actually, I have been involved with antibiotic research since my PhD in 2010. I started my PhD in 2010. So until now, I actually explored on antibiotic detection. And with this project, actually, it's actually give me opportunity to translate what I have been doing in research to translate to the real scenario, especially in patient care.
Okay, so now is the phase of transitioning or translating this research into real world settings, into hospital settings. Can you explain what needs to happen enable for you to be able to do that?
So one of it is because we have a funding so that we can analyze the real patients, because to analyze the big sample, we required funds, right? Because we need to buy chemicals, we need to buy some maintenance for instrumentation. So with this fund, actually, it actually support us to move forward from the laboratory to the patient. I mean, to analyze the real patient's plasma, and then we actually develop this system, which is the personalized dosing system for UNASIN.
So, because you are one of the Malaysian recipients of the L'Oreal UNESCO for Women in Science program, that comes with some monetary support. Will that allow you to do this, to translate, to bring it to the hospital setting?
Yes, because although it is not very much, I think, because but it still actually help us to like 30,000. It still support us uh to top up some of the funds that we already have. So we already established this under the university grant. So we carry out and do more validation study in the real patient samples. It's allowed us to do this.
Amazing. Okay. So I love that programs like this supports women in STEM, women in science, particularly mid-career women like yourself, because I think sometimes people assume that, you know, for scientists, let the work speak for itself, but in reality you need support, right? So talk to me about why it's important that we support and programs like this support women scientists like yourself, particularly in this stage of your careers.
I think funding is very powerful because it's actually enable the discovery, right? Especially any discovery in science, any research findings, it started with funding. If we do not have fund, we cannot start the research. But women scientists, I think we also needs environment that empower us to actually, for example, leadership opportunities, any mentorship activities, recognition and encouragement. I think with all these supports, women also, I think with all these platform like L'Oreal, UNESCO, and all the supports, women scientists can make a very meaningful impact. I think not only in Malaysia but also globally.
Yeah. Are you seeing that in your field that there is more support, structural support for women? Because we often hear that, you know, while there are many women in STEM, many of them, you know, they fall out of the career pipeline or they don't move up the ranks to leadership positions. What are you seeing? You know, you've been in this industry for some time. You've been working as a researcher for some time. Are you seeing things change for the better?
I think in my case, I'm not sure about others, but in my case, I have a lot of female postgraduate students compared to the male. But I'm not sure whether they actually will move forward becoming a scientist after this, I'm not sure about that. But at the moment, most of my postgraduate students, PhD and master students, most of them, they are female, which is good.
That
But I
is very good.
uh,
Yes.
this is a good things. But I think other than funding, all the support from from the government, from the agencies, we also need to have support from our family. I am lucky enough because I have a support from my family, who never stopped me to actually apply to becoming better for myself.
Wonderful. That's lovely. What is it that Dr. Noorfatimah, if I may ask you, based on this research, your work that you are hoping to move on to with real world settings, what are you hoping to achieve, or maybe what would success look like to you?
So to be honest, in this work, I actually work with my other two colleagues, who is a pharmaceutical background and also statistician. So we work together to form this personalized dosing system for UNASID. If this system, the personalized dosing, is implemented in hospital, it actually could transform patient care, because doctor will no longer rely on the general guideline. They can have the real data that tailored to each patient. This means that we can have more effective treatment, with fewer side effects, reduce risk of complications, shorter hospital stays, and of course, it will lower the healthcare costs and to control the antibiotic resistance. So I think overall is actually this research will strengthen our healthcare system.
That's really, really encouraging to hear. I am also very encouraged to hear that many of your postgraduate students are women. Do you have advice for young women today who are either thinking about pursuing studies or career in your field or in other scientific fields, but what advice would you give them to make sure that they see through maybe their potential?
So for me, I will advise to the young researcher or young students, young generation lah. What
Mm.
I will advise is that never give up and always try your best, because we actually learn when we fail. We actually learn and take it as a lesson for us. Okay, there is no failure, but instead we are taking that as a lesson and experience for us and keep moving forward.
Dr. Noorfatimah, thank you so much for speaking with me. And once again, congratulations on being recognized as one of the recipients for the L'Oreal UNESCO for Women in Science program. Well deserved. Thank you. We'll be right back after this, and we'll speak to another recipient of the program. So make sure you stay tuned to The Future is Female. We'll be right back. Hi, welcome back to The Future is Female. I'm Melisa Idris, and joining me now is one of the 3 Malaysian scientists recognized by the L'Oreal UNESCO for Women in Science program, Dr. Tan Ling Ling, who is a senior lecturer at the School of Engineering at Monash University, Malaysia. Dr. Tan, welcome to the show, and may I first say congratulations on being recognized and your work being recognized by such a prestigious program.
Thank you. Thank you for having me.
So let's get to know you a little bit better and get to know a bit more about your work. So tell me a little bit about yourself and how you ended up working in this field. So if I'm not mistaken, you are a materials scientist. So tell me about that. Not a lot of people are familiar with that field, I think.
All right. So hi, I'm Dr. Tan Ling Ling, a senior lecturer at the School of Engineering. And I'm also the director of the Nano Analytical Platform at the university. Yep. So my research focuses on photocatalysis, which is a technology that uses sunlight to drive chemical reactions. So how I would explain this is you can think of it like artificial photosynthesis. So just like how plants use sunlight to convert carbon dioxide into food, we design special materials that take sunlight and convert CO2 into fuels. And these fuels can be stored and used later as clean energy. So that's yeah.
How is that different from solar energy? Talk to me about because solar we frame it as a daytime solution, right?
So one of the main problems with solar technologies like solar panels is that they only work when the sun is shining. So when the light disappears during cloudy days or at night, energy production stops. And that greatly limits the reliability of solar energy. So my research aims to overcome this limitation by designing special materials that can continue producing solar fuels even after sunset.
Right. And what kind of special materials are there? Like how would it work?
We call these materials persistent luminescent nanoparticles, or PLNPs for short. So they basically behave like tiny rechargeable light batteries. So when there's sunlight, these nanoparticles would charge up, and later in the dark, they release the stored energy to keep the reactions going.
Is that challenging? I mean, technologically speaking, or conceptually, it sounds fantastic. But how do you go about doing that? What makes it scientifically challenging to have this photocatalyst system?
So this persistent luminescent nanoparticle, it is a relatively new material that we are working on. So currently, we're working on optimizing the efficiency and its long-term stability. Yeah, so the science is strong, but the engineering and durability under industrial conditions must first be validated before we can commercialize it.
Okay, and where are you at in terms of your research? The science you said is strong, so are you working into translating this into real-world applications?
At the moment, the research is still at the laboratory stage. Yeah.
Right. And what's next in terms of where you go from here? The L'Oreal UNESCO Women in Science program comes with some support, monetary support as well. Will that help with your research?
Definitely. This award will provide the resources for me to accelerate this research, particularly on the fabrication and testing of the said material. So once that is done, we can move on to subsequent phases, which include pilot scale reactor testing and so on.
Dr. Tan, can I ask you, what made you focus in on this? I understand that solar energy, there are issues with it being a renewable resource because of the inability to maybe store as much as possible. So when you are you were first embarking on this research for the day-night photocatalyst system, what made you think that this could be a viable option for us, for our energy in the future?
Yeah, because I've been working on photocatalysis for quite a while now, but the limitation, as mentioned, is that it is only active during the day. So that is why I chose to focus on this particular material system that could potentially work day and night. Yeah. So this will be very useful for households and for the industry.
I mean, I can imagine the potential of it. As a researcher, when you think about the way this could potentially change our approach to energy systems, what are you thinking? I mean, how do you make sure, or what is it that you wish would happen in terms of making your research something that's commercially viable and able to be have a real world application?
So I envision this technology being integrated into solar refineries. So these are basically systems that can continuously produce fuels, around the clock. And industrially, this technology could also be adopted at sectors focusing on carbon utilization, hydrogen production, and wastewater treatment. So there are quite a lot of things to do, but I'm quite optimistic that it will work out.
I'm optimistic for you, and I'm happy to see that organizations like L'Oreal, UNESCO are providing support for scientists, particularly women scientists, making putting effort or putting support into their work and giving an ability for you to be able to reach that potential. So when you think about the support that they've given beyond funding, what kind of support do you think makes the most difference for women scientists like yourself?
Yeah, I think visibility, mentorship, and trust can make a huge difference. So women scientists need to be seen, heard, and given the opportunities to lead. So programs like the L'Oreal UNESCO for Women in Science, they are very important, not only because they provide funding, but because they send a strong message that women can and should be at the forefront of science and innovation.
Is that, have you seen those areas improve in the time that you have been a scientist, a researcher yourself? The fact that increase in visibility or even mentorship and leadership opportunities?
Yeah, definitely. Yeah, because many areas of research are still male dominated, but I do see improvement in the environment. Yeah.
That is very encouraging. And where to next? So now that you have had this wonderful recognition for your research and the immense potential that it can bring, what's the next step, and what are you hoping to look in the next phase of your research?
The next phase of my research. So this project will focus on the development of the material, and hopefully this will open more doors for larger scale grants and long-term development. Because as mentioned, the research is currently done at the laboratory scale, but ultimately my goal is to develop a working prototype that can work under real-world conditions. So basically to bridge the gap from fundamental research to practical implementation.
Yeah, and think of the opportunities that it could have with renewable energies. Are you optimistic about when you think about the future of energy and the climate? What gives you hope? And if I may ask also, what frustrates you about it?
Well, what gives me hope is that is how rapidly the science and young talents are advancing. We already have many promising technologies to tackle climate change. But what frustrates me is how challenging it can be to translate these solutions from the lab into real world applications. But well, like I said, I'm optimistic that with continued research and support, technologies like photocatalysis can move beyond the lab and contribute meaningfully. Yeah, absolutely.
Yeah, scientific breakthroughs, research essentially is very long term. It's uncertain and it cannot really take years. How do you not lose motivation when progress can feel slow sometimes?
That's a good question. So, well, we need to persevere. And well, I've had many negative results throughout my research. But whenever we get positive results, it's very motivating. Yeah, and the thought that this could potentially contribute to clean energy one day keeps me going.
Oh, Dr. Tan, thank you so much for being on the show with me. And once again, congratulations on being recognized and awarded under the L'Oreal UNESCO for Women in Science program. I appreciate your time. Thank you for being on the show with me.
Thank you very much, Melisa.
That was Dr. Tan Ling from the School of Engineering in Monash University, Malaysia. And that wraps up this episode of The Future is Female. I'm Melisa Idris, signing off for the evening. Thank you so much for watching, and good night.